Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as definite integrals. Let's see this. We're going to do the next type today, which is called as standard formula. Now this is going to have everything in it. Integral of 0 to 1 2 minus x square upon 1 plus x square dx. Now this is a mixture of all your types. Okay. Degree of polynomial is same in the numerator and denominator. Since the degree of polynomial is same in the numerator denominator, you introduce the denominator in the numerator. So this is 0 to 1, 1 plus x square. You first thing have to get 1 plus x square here. Now I need minus x square. To get minus x square, I'm putting minus sign outside. That gives me minus 1. I want plus 2. So I'll write plus 3. Right, that's how I introduce the denominator and the numerator. Split the numerator. 0 to 1, this is minus 1 plus x square upon 1 plus x square dx plus integral of 0 to 1, 3 upon 1 plus x square dx. Cancel, so minus integral of 0 to 1 dx plus 3 integral of 1 upon 1 plus x square dx minus integral of x dx is x, integral of 1 upon 1 plus x square is nothing but tan inverse of x when the limits are between 0 to 1. It is upper limit minus lower limit, upper limit minus lower limit. This is minus 1 plus 3. Now we know that, guys, see this, we know that tan 45 is 1. If I take tan on the other side, I'll get 45 is tan inverse of 1. 45 can be written as pi by 4 is tan inverse of 1. So tan inverse of 1 can be written as pi by 4 minus tan inverse of 0. We know that tan 0 is 0, so tan inverse of 0 will be 0. So answer is 3 pi by 4 minus 1. Next, let's see another sum, guys. Integral of 0 to 1 x plus 4 upon x square plus 5 dx. The degree of polynomial in the denominator is greater than the numerator. You have two options here. Either you introduce the highest variable coefficient in the numerator, or you make the numerator to be the derivative of the denominator. First, I'm going to split the numerator. 0 to 1 x square plus 5 dx plus 4 integral of 1 upon x square plus 5 dx 0 to 1. Right? Now we know, guys, if I do the derivative of this, d by dx of x square plus 5 is 2x. d by dx of x square plus 5 is 2x. So we know that derivative of x square plus 5 is 2x. I want to make the numerator to be the derivative of denominator. How will I do it? Divide by 2, multiply by 2. Divide by 2, multiply by 2. Now my numerator becomes derivative of the denominator, right? Plus 4, 0 to 1, 1 upon x square plus 5 can be written as root 5 the whole square. Here you will use the formula f bar of x upon f of x. Right? The term in the numerator is derivative of the term in the denominator. So the answer for this will be log of denominator, log mod of x square plus 5. F bar of x upon f of x. Integral of f bar of x upon f of x is log mod f of x plus 4. Integral of, when the limits are between 0 to 1. Integral of x square plus root 5, 1 upon x square plus a square is 1 upon a tan inverse of x by a. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. So 1 upon a tan inverse of x by a when the limits are between 0 to 1. So this is going to be equal to 1 by 2 upper limit minus lower limit, log of 1 plus 5 minus log of 0 plus 5 plus 4 upon root 5 tan inverse of 1 by root 5 minus tan inverse of 0 by root 5. This is 1 by 2 log 6 minus log 5 plus 4 by root 5 tan inverse of 1 by root 5. Tan inverse of 0 is 0. Log A minus log B is log A upon B. So this is log 6 upon 5 plus 4 by root 5 tan inverse of 1 by root 5. Right? That will be the answer. Yeah.
Put the root 5 outside.
Which root 5 outside?
Taking 4 by root 5.
Yes.
So why are we taking the inside getting it?
This is 4 by root 5 and this is my angle x by root 5.
Okay, now 1 by 8.
Right? 1 upon x square plus a square is 1 upon a tan inverse of x by a. Right? Next. Let's see the next one, guys. Integral of 2 to 3 dx upon x square plus 5x plus 6. I have a quadratic. Now I can find the factors of this quadratic because x square plus 5x plus 6 can be written as x plus 3, x plus 2. That means I can solve this sum by two methods. Either I can solve this by quadratic or I can solve this by partial fractions. Since I am able to get the factors, if I was not able to get the factors of the denominator, if I was not able to get the factors of the quadratic, then I would have had to solve the problem by finding out the last term and quadratic method. Here I am able to do it, so I can use any one of the two methods. We will do one thing, we will use say partial fractions. So this can be written as 2 to 3 dx I is equal to 2 to 3 x plus 2 x plus 3 quadratic factors, right? I could have done it by any method. You can do it by quadratic method and get the answer. I'm doing it by partial fractions, right? Let's see this. You will say that let 1 upon x plus 2 x plus 3 be equal to a upon x plus 2 plus b upon x plus 3. Therefore I can say that 1 is equal to a x plus 3 plus b x plus 2. What did I do? I took LCM and the common denominator got cancelled. Now I want to make this bracket as 0. To make this bracket as 0, I'll say let x be equal to minus 3. So I'll get 1 is equal to b minus 3 plus 2. 1 is equal to minus b is equal to minus 1. Now I want to make the second bracket as 0. So you will say let x be equal to minus 2. 1 is equal to a minus 2 plus 3. 1 is equal to a. Once I have this, then I can say therefore I is equal to integral of 2 to 3 a. That's 1 upon x plus 2 plus b minus 1 upon x plus 3 dx. Right? Now split the integral. This is going to be integral of 2 to 3 1 upon x plus 2 dx minus integral of 2 to 3 1 upon x plus 3 dx. Integral of 1 upon ax plus b is 1 upon a log mod ax plus b. A is 1, so this is log mod x plus 2 when the limits are between 2 to 3 plus minus log mod x plus 3 when the limits are between 2 to 3. Right? How do I solve this? This is upper limit minus lower limit. So log of 3 plus 2 minus log of 2 plus 2 minus log of 3 plus 3 minus log of 2 plus 3. Upper limit minus lower limit. So this is going to be log 5 minus log 4 minus log 6 minus log 5. So this is log 5 minus log 4 minus log 6 plus log 5. Minus into minus is plus. This is 2 log 5 minus log 4 minus log 6. 2 log 5 can be written as log 5 the whole square. 2 log 5 can be written as log 5 the whole square minus log 4 minus log 6. Addition changes to multiplication, subtraction changes to division. So this is going to be log 25 upon 4 into 6. Subtraction changes to division. Both of them come in the denominator. So your answer is log 25 by 25. Next, let's see the next sum, guys. Integral of a to 2a dx upon root of 2ax minus x square. Quadratic, right? I need to find out the last term. Last term is given by the formula middle term into middle term upon 4 times first term. Middle term, that's 2ax into 2ax upon 4 times x square. So this is going to be a square. Observe carefully. I can say I is integral of a to 2a dx upon square root of, I'm taking minus sign common. So in this case this will be x square minus 2ax. If I take minus sign common here, you will get x square minus 2ax plus a square. If I am writing plus a square in the bracket, that means in reality I am subtracting a square, because plus into minus is minus. I am subtracting a square, I am adding a square. I am subtracting a square, I am adding a square. This is going to be integral of a to 2a dx square root of, this is going to be a square. Since I have found this as a perfect square, this is going to be nothing but square root of the first term, square root of the last term, sine of the middle number. So this is going to be x minus a the whole square, right? Integral of a square minus x square is nothing but sine inverse of x by a. Integral of a square minus x square is nothing but sine inverse of x by a. Integral of root of x square minus a square minus x square is nothing but sine inverse of x by a. So in this case, this is going to be equal to sine inverse of x minus a upon a when the limits are between a to 2a. Right? How do I solve the limits? Upper limit minus lower limit. So 2a minus a upon a minus sine inverse of a minus a upon a. Upper limit minus lower limit. So this is going to be sine inverse of 2a minus a is a upon a is 1 minus sine inverse of 0. We know that sine 90 is 1. So sine inverse of 1 will be 90. Sine of 0 is 0. Therefore sine inverse of 0 will be 0. So your answer is pi by 2. Next, let's see the next one, guys. Integral of 1 to e log x. We do not have a formula for log. We do not have a formula for log. So how do I solve this? This is 1 to e log x into 1 dx. Log x can be written as log x into 1. 1 can be written as x raised to 0. Here I can use parts, that is I'll have to use late, log is first and algebraic is later. We will be using the formula integral of uv integral of uv is u integral of v minus integral of v derivative of u dx. Now observe carefully here, guys. The limits do not come for the second integral sign, they come only for the first integral sign. Okay, now this is going to be log x. Integral of x raised to 0 is x when the limits are between 1 to e, minus integral of 1 to e, integral of x raised to 0 is x, derivative of log x is 1 upon x dx. Right? So this is going to be x log x when the limits are from 1 to e, minus integral of dx when the limits are from 1 to e. Right? This can be written as upper limit minus lower limit, e log e minus 1 log 1, minus integral of dx is x when the limits are from 1 to e. E, value of log e is 1, value of log 0, log 1 is 0, minus e minus 1. So this is e minus e plus 1, answer is 1. Next, let's see another sum. Integral of 0 to 2 x e raised to x dx. X is algebraic, e raised to x is exponential. So you will have parts. U integral of v minus integral of v derivative of u dx. So in that case this is going to be x. Integral of e raised to x is e raised to x when the limits are between 0 to 2. Integral of e raised to x is e raised to x. D by dx of x is 1 dx. This is nothing but upper limit 2e square minus lower limit 0 e raised to 0, minus integral of e raised to x is e raised to x 0 to 2. This is 2e square minus upper limit minus lower limit. Right? So this is 2e raised to x e square, 2e square minus e square, minus into minus plus, anything raised to 0 is 1. So 2e square minus e square is e square minus 1, e square plus 1. Right? Next, let's see another sum, guys. Integral of tan inverse of x dx and the limits are between 0 to 1. Right? Again, we don't have a formula for tan inverse, so you will do 0 to 1 tan inverse of x into 1 dx. 1 can be written as x raised to 0. So this is tan inverse of x into x raised to 0 dx. You will use parts. So here inverse and this is exponential, right? So this is u integral of v minus integral of v derivative of u. Right? So let's solve this. This will give me tan inverse of x integral of x raised to 0 is x when the limits are between 0 to 1 minus integral of 0 to 1 integral of x raised to 0 is x. D by dx of tan inverse of x is 1 upon 1 plus x squared dx. So this can be written as x tan inverse of x when the limits are between 0 to 1 minus integral of 0 to 1 x upon 1 plus x squared dx. Now, the degree of polynomial in the numerator is less than that of the denominator. I can make the numerator to be the derivative of the denominator. Here I can substitute 1 tan inverse of 1 minus 0 tan inverse of 0. Upper limit minus lower limit. Minus. To make this as derivative, I am dividing by 2, I am multiplying by 2. Divide by 2, multiply by 2. Why did I do that? Because d by dx of 1 plus x square is 2x. So that I could make the numerator to be the derivative of the denominator. 1 as it is. Tan inverse of 1. We know that tan 45 is 1. So tan inverse of 1 will be 45. Anything multiplied by 0 is 0. 1 by 2. The term in the numerator is derivative of the term in the denominator. Therefore, this will be log mod of denominator when the limits are between 0 to 1. This is pi by 4 minus 1 by 2. Upper limit minus lower limit. Log of 1 plus 1 minus log of 1 plus 0. This is pi by 4 minus 1 by 2. This is log 2 minus log 1. But we know that the value of log 1 is 0. So the answer is going to be pi by 4 minus 1 by 2 log 2. Right? Next, let's see the next one, guys. Integral of x upon x plus 2 x plus 3 dx when the limits are between 2 to 3. Right? Let's see the sum. Straightforward partial fraction. They have already factorize the thing and given to you. So you will straight say that let x upon x plus 2 x plus 3 be equal to a upon x plus 2 plus b upon x plus 3. Therefore, you can say that x is equal to a times x plus 3 plus b times x plus 2. LCM, and I cancel out the common denominator. Now you will say let x be equal to make this number as this bracket as 0, you will say let x be minus 3. So in which case you will get minus 3 is equal to b minus 3 plus 2. Minus 3 is b into minus 1, b is 3. To make the second bracket as 0, you will assume x to be minus 2. Minus 2 is a, minus 2 plus 3, minus 2 is a. Once I know this, I can say I is integral of 2 to 3 a minus 2 upon x plus 2 plus b 3 upon x plus 3 dx. Split the integral. This will be 2 to 3. Constant comes out, minus 2 out, 1 upon x plus 2 dx plus 3 integral of 2 to 3, 1 upon x plus 3 dx minus 2. 1 upon ax plus b log mod ax, 1 upon a log mod ax plus b when the limits are between 2 to 3 plus 3 log mod x plus 3 when the limits are between 2 to 3. This is minus 2. Upper limit minus lower limit. 3 plus 2 log minus log 2 plus 2 plus 3 log 3 plus 3 minus log 2 plus 3. This is minus 2 log 5 minus log 4 plus 3 log 6 minus log 5. Open the brackets. This is minus 2 log 5 plus 2 log 4 plus 3 log 6 minus 3 log 5. So this is going to be 2 log 4 plus 3 log 6 minus 5 log 5. right? That will be your answer. Fine. Next, let's see the next sum, guys. This was the 9. Integral of 2 to 3 dx upon x cube minus 1. Right? Let's see this. Now, the degree of polynomial in the numerator is less than that of the denominator. In that case, either I make the numerator to be the derivative of the denominator. In this case, this is not possible because I don't have an x in the numerator. Or I introduce the highest variable from the denominator into the numerator. So in this case, I'll have to do that. This is 2 to 3. I see this. This is x cube minus 1. Right? I have a 1 here. Right? Add x cube, subtract x cube. So in that case, you will have add x cube, subtract x cube dx. I am introducing the highest coefficient, no, highest degree variable from the denominator into the numerator. Right? Now, this can be written as 2 to 3. I could take 1 minus x cube upon x cube minus 1 dx plus 1 minus x cube is gone, so plus 2 to 3 x cube minus 1 dx. Right? Now, this can be written as 2 to 3. 1 minus x cube is 1 minus x, 1 plus x square, using the formula a cube minus b cube, x need not expand, I could have directly cancelled. Take minus sign common in the numerator, so you will get x cube minus 1 upon x cube minus 1 plus this becomes x square. So I'm going to divide by 3, I'm going to multiply by 3. Why did I do that? Because d by dx of x cube is 3x square. I wanted to make the term in the numerator to be the derivative of the denominator. Now this and this gone, so this is going to be minus 2 to 3 1 upon x dx plus 1 by 3 2 to 3 3x square. I'll do this in the next step, guys. X cube minus 1 dx. I'll do both of them together. Minus log mod x when the limits are between 2 to 3 plus 1 by 3 log mod x cube minus 1 when the limits are between 2 to 3. Minus upper limit minus lower limit. So this will be log of 3 minus log of 2 plus 1 by 3. This is going to be log of 27 minus 1 minus log of 8 minus 1. So this is going to be negative log 3 plus log 2 plus 1 by 3 log of 26 minus log of 7. Now, this can be written as log of 2 upon 3 plus 1 by 3 log of 26 upon 7, right? Now, I want to get 1 by 3 common. So what I'm going to do is, I'm going to divide by 3, multiply by 3. Observe this carefully. I'm dividing by 3, I'm multiplying by 3. Log 2 by 3 plus 1 by 3 log 26 by 7. Now I could take 1 by 3 common. If I take 1 by 3 common, 1 by 3 comes out. 3 log of 2 by 3. Whatever is the number before the log goes up in the index. So in that case you will get this as log 2 by 3 the whole cube plus log 27 by 7, sorry 26 by 7. This is 1 by 3 log 8 upon 9 plus log 26 upon 7, sorry 3 upon 27, right? Now addition changes to multiplication, so this is going to be equal to 1 by 3 log 8 into 26 upon 27 into 7. So this is going to be 1 by 3 log of 208 by 189. Right? This finishes the sum. We'll stop this here for the day. Thank you very much.